So hi everyone. So today we're going to look at the analysis of experiment we did on helical spring, Waec 2023 Alternative A Physics examination. If you have not viewed the video, you look at the video. The video is done in the last post in this YouTube Best Science Brain. So you go and look at the video for the experiment. But now we're trying to discuss the result of the experiment as we have it here. So here, this is the spring we used in the video, the helical spring. And then here, what the first thing we did was measure the length of the spring, the original length of the spring from this point to this end, which we have here as LO. Original length of the spring is 7.500 centimeter when we measured it. Then we also use a mass hanger. The mass hanger we use in the experiment has a mass of 50 grams. That's a mass hanger with a mass of 50 grams, 50.00 grams in the experiment. So we have the slotted masses. Then what did we do? We measured the length of the spring at 7.500 cm, and then in the first experiment what we did was we hung the mass hanger. So in the first experiment, measure the length of the helical spring at 7.500 cm. Then we hung the mass hanger. The mass hanger, as we said, is 50.00 gram. I was slotted in a mass of 20 gram on it. So a mass of 20 gram. And then there was extension and incremental length. We now measure the new length of the spring. We did it for the 20 gram, did it for 40 gram, did it for 60 gram, and did it for 80 gram. In each case, we measure the new length of the spring. So if we go to the result we have here on the table, we have the first mass hung on the hanger is 20 grams. That M stands for mass, unit is the grams. The length we got after hanging mass of 20 grams was 12.0 cm. Then extension was obtained. The extension is this length, which is L, minus the original length, LO. The length L here is 12 minus original length 7.5. 12 minus 7 gives us 4.500 cm. That's the extension. Then we set the 20 gram mass into 20 vertical oscillations, and we'll obtain a time of 18.78 seconds. 18.78 seconds. We repeated the experiment again, and then we got a time of, with the same 20 gram, we have to repeat the oscillation for another 20 seconds. For another 20 oscillations, we now obtain another time of 19.85 seconds. We now took the average of this time, 18.78 plus 19.85 divided by 2. We now got 19.32 seconds as our time, mean time. We now found the period. Period is the average time over number of these 20 oscillations. We now got 0.9660 seconds. Then we did t squared, period squared, capital T squared. We got 0.9332 seconds squared. Then with a mass of 40 grams, we set the spring before the oscillation. When we hung the mass of 40 grams, we got a new length of 13.50 seconds. We now have to get the extension. The extension is this 13.50, which is L 13.50 minus 7.5, which is the original length. I will got 6.000 centimeter. Then we set the 40 gram 40-gram mass into 20 vertical oscillations, and we now got 21.02 seconds. Repeated it again, and we got 22.03 seconds. We took the average, 21.02 plus 22.03 divided by 2, we got 21.53. We have to find the period by dividing time over number of oscillations. That is the mean time, 21.53 divided by 20, we got 1.077 seconds. Then we did period square, that capital T square, 1.077 square, giving us 1.160. Then we now took the mass of 60 grams. Then we hung it on the spring, and then we got a new length of 15 cm. The extension, as usual, was obtained by using the new length 15 minus original length of the spring. 15 minus 7.5 also gave us 7.5. We now subjected the 60-gram mass into 20 vertical oscillations, and we obtained 24.59 seconds. We repeated the thing again, and we also obtained 24.64 seconds. We took the mean time by adding 25.59 to 24.64 divided by 2, we got 24.62 seconds. We now found the period. Period is the mean time over number of oscillations. That is 24.62 over 20 will give us 1.231 seconds. We now did period squared. 1.231 squared, we got 1.515 seconds squared. Then we increase the mass to 80 grams. With the mass of 80 grams, the new length was 16 cm. The extension is the new length L minus original length LO. L here is 16, LO is 7.5, and that gives us 8.500 cm. We subjected this mass of 80 grams into 20 vertical oscillations, and we obtained 25.49 seconds. Repeated it, we obtained 26.60 seconds. We took the average, that the mean time, 25.49 plus 26.60 divided by 2, got 26.05 seconds. Then we have to find the period. Period is capital T, small t, the mean time over 20. We divided 26.05 by 20, and we got 1.303 seconds. We now did period squared. 1.303 squared gave us 1.698. Then the fifth, we now had a mass of 100 grams. Another mass of 100 grams, and on the helical spring, we now got a new length of 16.50 cm. The extension is 16.50 minus 7.5, giving us 9.00. The extension, remember, is the new length, which is L, and the original length, which is LO. LO is constant, 7.5, while the new length is the length you obtain after hanging these masses. So for the 100 grams, the new length is 16.50, original length is 7.5. Once subtract, you have 9.00. We have to subject this 100 grams into 20 vertical oscillations. The first, we got 27.02 seconds. Repeated it, we got 26.72 seconds. Then we took the average of the time, 27.02 plus 26.72 divided by 2, we have 26.96 seconds. Then we now have to calculate our period using mean time over 20, which is 26.96 over 20. We got 1.348 seconds. Then period 1.348 square gave us 1.817. So this is the data for the experiment. Then after that, we have to plot